Okay, so this video is covering the beginning of section 1.3. I'm labeling it here as 1.3.1 because it's the first part of section 3.1. We'll spend 2 days going over this. This video goes over the first, the first 2 pages of these notes. Okay, so these aren't, this slide is not represented in your notes, so just, put your notes aside and listen to this one. When we are trying to design some kind of statistical study, there's a couple of things that we do. So first, we want to identify what variables that we're interested in. What are we going to focus on, right? And what is the population that we want to know something about? And what is that something we want to know, all right? 2, we want to develop some kind of detailed plan. How are we gonna collect data, right? Are we gonna use a survey? Are we going to use an experiment? And we'll go through all the different types of studies in the next couple of slides. But here we just got to figure out. We're just giving you like an overall how to plan for when you go to create some kind of statistical study. Okay, we want to make sure that when we sample, when we ask people questions, that those people were randomly selected from the population. So if I want to, if my population is seniors at Montclair High School, and I want to know what, how likely are you to go to prom this year, right? So are you planning on going to prom or not? That's the variable I want to ask about. And so I want to make sure that the sample I choose is representative of the whole population of seniors. So I can't just ask my period 6 probability and statistics class, right? It's maybe not a true representative sample. So often our samples will be selected randomly, and we'll talk about that later on in this section. All right, we're going to actually collect the data. Maybe that means running an experiment, maybe running the study, whatever the study is, we're going to execute the study and collect the data. And then we're going to use, the descriptive statistics that we're spending, the better part of this year talking about to describe what's going on. In our case, in my example, I would calculate the sample proportion. What proportion of students in my sample are going to prom, right? That would be my descriptive statistic from my study. And then I would want to interpret that data and infer back to the population. So if I was meeting with Mr. Friedman to plan this year's prom, I would tell him, hey, look, 35% of my sample said they were going to prom, so we're going to assume that 35% of all seniors are going to prom. Assuming I took my sample in a legitimate manner, it should be fairly representative of the population. So if 35% of my sample said they're going to prom, then we can infer, using inferential statistics, infer back to the whole senior class, the population, that 35% of them are going to prom. And then we want to look for any possible errors. What could have gone wrong? What did we do that we should do better next time? Okay, so when we collect the data, we have different methods of collecting data, and these are called studies. And the first study, that first type of study that we're going to talk about is called an observational study. And it really is just researchers measuring some kind of characteristic, but it's not interacting with them. It's watching and seeing what happens. So the example we have here is if we're researchers and we're interested in the behaviors of 3-year-olds, we might want to know what, in this case, we're going to watch, observe, right? We're not going to interact with them. We're just going to watch them and see what they do. Like, so we're going to, in this case, a study of the mouthing behavior for non-food items for, students, for children younger than 3. So we put a bunch of 2-year-olds or 3-year-olds in a room. We put a bunch of items in there that are not food, and we see, do they stick them in their mouths? Do they, chew? How long do they chew on them? We might measure a couple of different things, but we're not interacting with them. We're not trying to get them to do something. We're just watching what happens. So the next type of data studied to collect data is called an experiment. So in an experiment, you're actively creating some kind of environment or a treatment. So you're imposing a treatment on on part and then seeing what happens. Like you know, we want to see if there is some kind of response if we impose some sort of treatment. Now, when we do, we'll get into more details. We'll explain a little bit more details what this all means. But when you run an experiment, it's the only type of study where you can show a cause and effect, right? Something that we hear a lot about lately is is clinical trials for coronavirus, for the the vaccine that they developed for the coronavirus. So if you have volunteers who come and say, yes, I'd like to participate in this study, then you take those 2 volunteers and you break them into 2 groups. And so one group will get the vaccine in a shot. The other group will get a shot as well, but it won't be the vaccine. It'll be something that looks like the vaccine, and they won't know. Nobody knows what group they're in. This is called a blind study when you don't know what you're getting. So I get stabbed in the arm, but I don't know if I got something called the placebo, which is a fake. It's not anything that's going to harm me, but it's not. It doesn't have the active ingredient. Right? So we might do a similar thing for like headache medicine. So if you have headaches, then you might be part of a clinical trial, and you're broken into 2 groups. And one group is going to be given a bottle of pills to take every morning, and the other group gets also a bottle of pills to take every morning, but only one of the groups has an active ingredient, right? So they have a new medicine to help with headaches. And the second group, sometimes referred to as a control group, they will get no treatment. Or sometimes they might get the old treatment, like, okay, this is the old headache medicine. Or they may get what's referred to sometimes as a sugar pill. So it's a pill that has no active ingredient in it, but you don't know. You're just putting it in your mouth, you're swallowing it, you don't know what group you're in. Okay, so that is a good experiment. We'll have 2 groups at least, and one group gets the treatment and the other one gets a sort of a fake treatment. Okay, and then we look in the coronavirus example, one group gets shot, one group doesn't get a shot or thinks they get a shot, but they're not really getting a vaccine. And then you look and see, did we get more coronavirus showing up in the group that didn't get the vaccine? Now, this might sound kind of cruel, like, whoa, wait a minute, now you're putting these people in danger. But the problem is there's no way to really know for sure whether this new vaccine is effective, unless we have a group that's getting it and a group that's not getting it, right? And so it's crucial for clinical trials for there to be what we call a placebo or a control group that gets the old treatment. All right, so a simulation, the third type of data collection method in a study, that's called a simulation. So we use some kind of mathematical or physical model to reproduce a condition or a process. Usually this is some kind of dangerous scenario that we don't really want to go out in the real world and start run the simulation in the real world, because people could die, and often that would be a bad thing. And so often we're going to use computers to simulate this. So for example, we build a new car, we send it to the lab, they put dummies in it, they run it up to speed and crash it into a wall and see how well the dummies are full of sensors, and like, okay, would the dummy have gotten broken legs and broken ribs, or what would have happened if that had been a real person in the car? And so that's a simulation. Sometimes we'll do computer simulations. So how a virus is going to spread, right? So we might do simulations on how quickly a virus could spread in a community. We don't want to release a virus and watch, see how it spreads, that would be bad, right? So that was a dangerous situation. So we'll use computer simulations sometimes to collect data, and most often it's because to run the real simulation, the real world, would just be too dangerous. All right, and the fourth method for collecting data, the fourth type of study is called a survey. And so you will just actively ask people questions. You can do that over the phone, over the internet, emails, over the mail. So you get a survey in the mail, and you fill it out and you send it back, right? Something like that. So in this case, we have a survey that's conducted and a sample of female physicians, and we want to determine what we're interested in is determining what was the main reason or the primary reason they became a doctor. Was it for financial stability, or what was it for, right? So we would send an interview, we would send in a survey to them through the mail, or maybe we would try to contact them. Maybe we go to the hospital and we track them down and we ask them questions. It can be person to person, or it can be over the internet, or through a phone call, or snail mail. All right, so with this slide, I want you, so we have our four methods, our four data collection methods. Hopefully you wrote all those down in the previous slides, and you have them in your notes. And so now we have four studies that we're talking about, and you are supposed to put down, is it an experiment? Is it an observational study? Is it a survey? Or is it a simulation? I think I said all four. So which of there's four things here. Each one shows up once. Pause this video, give yourself some time to work through this, and then start the video back up again. Okay, so number one, a study of the effect of changing flight patterns on the number of airplane accidents. So that seems kind of dangerous. I wouldn't want to change the pattern and then see how many accidents occur. That was kind of dangerous. So this will be done through some sort of computer simulation. It would just be impractical to create that situation, and dangerous. You don't want to see how many accidents you have and then decide whether it was a good idea or not. All right, number two. So number one was a simulation. Number two, a study of the effect of eating oatmeal on lowering blood pressure. All right, so one of the key words that is going to tell you what's going on here is the effect of eating. So remember that cause and effect is only shown through an experimentation. So this sounds like we would give some people oatmeal to eat in the morning, and other people would not get oatmeal. I mean, don't give us this kind of details, but for a good experiment, you would have some people eating oatmeal, some people saying, you'd be telling them not to eat oatmeal, and seeing if the people who are eating oatmeal have lowered blood pressure at the end of 2 months or whatever. So this is definitely an experiment. We're measuring the treatment. The treatment is you make some people eat oatmeal, some people don't get to eat oatmeal. And so that is the treatment that you're going to impose on them. All right, number three. A study of how fourth grade students solve a puzzle. All right, so you're just going to give them a puzzle, and you're going to watch and observe, right? See how they solve it. Maybe you'll make note of how fast they solve it or something like that, right? So that is an observational study. You're not really imposing a treatment. Some people aren't doing it with one hand tied behind their back, or with one eye closed. I mean, we're not imposing any kind of treatment on it. We're just giving them a puzzle and observing what happens. So that's definitely an observational study. All right, and then the last one, well, there's only one left, but a study of U.S. residents' approval rating for the U.S. president. So that we would collect that data by asking people, hey, do you approve of the job the current president is doing, yes or no? And so we would collect that data using a survey. All right. All right, so let's look at example 5. A study of the effects of using MyStatLab, that's a web-based program, on grades in a statistics course. All right, so what is the research? What is the focus of the research that we're doing? Like, what are we trying to do? All right, so we're trying to look and see, does using this software affect your grade? Hopefully it would improve your grade. I don't know, maybe it's a really bad software and using it would make your grade worse. But we want to see what the effect of the grade is for students who use this. All right, what population is under study here? Well, this would be what? Students taking statistics, right? So if you're in a statistics class, then you're part of the population that we would want to see if this would help you. All right, so C, what method of data collection would be most appropriate for this? All right, and so experimentation is because that effect, right? That's what we're looking for. Study of the effect of using it. And so we can only show cause and effect by doing an experiment. We can't ask people, hey, have you used this lab? Oh, and so what's your grade? That's like an observational study or maybe a survey, right? So here we are imposing it. So to run this, we have a bunch of volunteer statistics students, and we would break them into two groups. And one group would use the software, one would not, and we would see is the grades for the class, for the group that's using the software, better than the grades of the people who are not using the software. All right, so let's consider the following statistical studies. Which method of data collection would you use to collect the data for each? So again, pause this video and then try 6 through 9. When you're finished, then restart the video. Okay, number 6, a study of the effects of exercise on relieving depression. So we want to know whether or not exercise is going to affect someone's depression or not. All right, so again, the key word is effect there, so this is going to be an experiment. Some people are made to exercise and other people would be asked not to exercise. And we would see if there's a difference in the depression level of the student. You know, did your depression improve, right? So this population here would be people suffering from depression. All right, number 7, a study of the success of graduates of a large university in finding a job within 1 year after graduation. Okay, so how would we collect that information? Well, we would have to use a survey, right? So we would try to find those students a year after graduation and ask them, hey, do you have a job, right? So we would ask them through a survey. All right, the number 8, the effect of new automobile seatbelt design in reducing deaths in car crashes. Well, it does say effect here, right? So it sounds like maybe you would run an experiment, but would you want to put some people in the car with the new seatbelt design and people in a car with the old seatbelt design and see who dies more often? Probably not. That is dangerous, right? So we would do some kind of simulation. We'd use a test dummy and run that and collect the data. Okay, number 9. Watch and record toy choices of toddlers based on their gender. So we would record the toddler, look through maybe a two-way glass, right, or two-way mirror, and watch toddlers in a room and look at their gender and look at the toys they pick up and make a study of that. So this is an observational study, right? We're not giving them things or making them do things. We're just sitting back and observing, watching and recording what toys they pick up based on what gender they are. Does the gender predict what toys they would pick up? All right, so some terminology. All right, so we're going to use this example in the next couple of slides. Suppose that we're interested in determining the effects of room temperature on the performance on a first semester calculus exam. So this would be a college exam, first semester, college, Calc 1, and we want to know does the temperature in which they of the room in which they take the test, does that affect their grades? So we're going to run an experiment. And so what variable will we measure? What are we measuring? So think about this. This is what the output from, what is this experiment going to measure? And so it's going to measure their grade, their performance, usually as a score or grade on their test. All right, and so that is referred to as a response variable. So the response variable, we're not controlling that. We're not adjusting that. What we're doing is we're going to run the experiment, and the response variable is what we're going to measure. See what grade you got, or what score, or what performance. All right, and then what variable will explain the results? So we're hoping, we're investigating. Like, what are we investigating? We're investigating whether temperature affects that. So the temperature of the room is going to be the what explains the so we think colder rooms, students will do better in colder rooms because they're less likely to fall asleep, maybe, or something like that, right? So we expect some result, and we're going to test it in running this experiment. So this is referred to as the explanatory variable. It's the variable that explains the results. Like, oh, the results are better if you're in a cold room, or maybe the results are better if you're in a hot room. So that's what it's going to be. And the different levels of that explanatory variable will be referred to as factors. Okay. So in our situation, we decide, okay, let's have two rooms, two different temperatures. So one temperature, some rooms will be 65 degrees and some will be 75 degrees. So there are two different temperature settings. And so how many treatments do we have? Well, the treatment is the particular combination of explanatory variables. And so our explanatory variable here is simply the temperature. And so we have two treatments. They are the two temperature settings. All right, so two treatments because we have two temperature settings. We can think of that as two different factors, right? So we have two different levels of one factor. We have two different temperatures. All right, suppose that we have 10 sections, so 10 classes of first semester calculus that the professors have said, oh yeah, you can use my class for this study, that's fine. And so we have to think about on who or what are we imposing treatments. So at first you might say, oh, well, we're imposing it on the students, right? The students, but the students aren't all getting varied temperatures. It's the class. So the entire class really is what we're thinking about as far as who's getting the treatment. And so it's the 10 sections of calculus because everyone in that one class is getting the same temperature. It's not the individual people are getting different temperatures. And so we refer to those 10 sections, those are the experimental units. So it's the smallest unit on which a treatment can be applied. And then if we're using humans, if like the subjects are human, then we call them subjects, right? Otherwise, we kind of refer to them as experimental units. And in this case, we don't really think of we think of them as experimental units rather than subjects because it's each class, each of the 10 sections or classes that is the experimental unit because that whole group of kids in that one class are getting the same treatment. All right, so how would we determine which sections, right, get rooms that are at 65 and which sections get rooms that have temperatures set at 75? And so we have to do that randomly. We can't just let the professor choose or let the students vote. What temperature do you want to have this test at? We have to impose that treatment. So we have to, 5 classes are going to be at 65 degrees and 5 classes are going to have their temperature set at 75 degrees. And the best way to decide which one's which is randomly. And so by randomly assigning them, we can kind of then say that the 5 classes that are getting one treatment are going to be as similar as we can to the 5 classes that are getting the other treatment. All right, so random assignment is really, really important. It ensures that we don't have systematic favoring, right? So if all the kids who, if you ask the kids and they all say, oh, I like a cold room, you can't do that, right? You can't let the kids decide or the professor decide what temperature the room is going to be. You have to set that. Okay, so how do we decide? We have 10 sections and we have 2 treatments. So we have to figure out which 5 are going to which. And so the simplest way is just to randomly pick them. And so that might sound simple, but it's actually it can be sometimes an arduous process. And we're going to learn later in this section more complicated ways to do this. But the simplest way is to just put 10 identical pieces of paper, each with a number of 1 through 10, and put them in a hat. And then shake the hat really well and just pull 5 names out. So five slips out. So we randomly pick 5 of the numbers from the hat, and we're going to assign those 5 numbers, those 5 sections, right? Each section is numbered 1, 2, 3, 4, 5. And so, for example, the first number we pick is a 9. So section 9, class 9, will get 65 degrees in their room. And then the next one is 7. I'm just randomly picking cards out of the hat. The next one is 5. The next one is 8. And the next one is 3. So I just randomly picked 5. Now I don't need to pick the other 5. By default, the other 5, the remaining 5, just get placed into the other room. Okay? So by randomly picking 5, I've also randomly picked the other 5 by default. All right, so let's try this. Read through this, and then I'm going to have you put the video on pause while you answer the questions down below. So describe which in the scenario, which of them is an experimental unit, right? Which one is an experimental unit? Which one is what are the explanatory variables, the response variable, and how many treatments we have? Okay, so let's read through. A farm product manufacturer wants to determine if the yield of a crop is different when the soil is treated with 3 different types of fertilizer. 15 similar plots of land are planted with the same type of seed, but are fertilized differently. At the end of the growing season, the mean or average yield from the sample plots is compared. All right, so now think about what are the experimental units? What are the explanatory variables? What's the response variable? And how many treatments do we have? So pause this video and then write out those things on your notes. And then when you're finished, unpause the video. All right, so the experimental units, those are the 15 plots of land, right? The 15 similar plots of land. And the explanatory variable, so we're hoping that that's going to explain what's happening, right? So that's what we vary, and so that's going to be the 3 different types of fertilizer, right? So the type of fertilizer is the explanatory variable. We're thinking that that's going to affect the yield or the outcome, like how much is produced on the land. Response variable, what are we going to measure? We're going to measure the yield of the crop. That means like how many bushels per acre do we get, something like that. And then how many treatments are there? Well, there were 3 different types of fertilizer, so 3 is the number of treatments. Okay, so everybody's getting some kind of fertilizer, but there's just 3 different types. So there's not really a control here. We're not really, maybe one of the fertilizers is the fertilizer we use every year and we're trying 2 new types. Who knows? They didn't really give us those details. All right, some more terminology. Confounding variables. All right, so this is a little confusing, but confounding variables occur when an experiment cannot tell the difference. Usually it means we didn't run the experiment really well, right? So something happened, right? Something we didn't account for happened. And so we don't know whether or not the results we got were from the explanatory variable or whether it was from some other variable that we didn't control for, that we did not include in our treatments. All right, so here's an example. A coffee shop owner decides to remodel her shop. At the same time, a nearby mall has its grand opening. So she's thinking, now it's not it's not a really great example of an experiment, but she's going to do she does some treatment to her shop, right? She updates it, she paints, maybe she puts in new flooring, everything looks nice, right? She's spending some money updating her shop. But at the same time, a nearby mall has its grand opening. All right, so she finds that her business has increased. So the result, the response variable is how much does her business increase? And her business does increase. Now the problem is, well, we don't know. She doesn't really know whether it was the remodeling. People love her new, they're coming to check out her new remodeling, and that's why there's more people than usual. Or there's more foot traffic because a nearby mall opened, and so now people are driving by, and so she's got a bigger business because of that, right? So she doesn't really know what caused the increase in business. It could be the remodeling had the effect she was hoping for, and that's what's causing people, hey, this place looks really great, and word of mouth gets around that it's a really nice new shop and that people want to go there, right? But it could be that it's really just there's just more people in the area because of the new mall opening. Okay, all right. So next one. So let's continue talking about the temperature in the room experiment that we're talking about. Remember that the explanatory variable in the room is the temperature setting. So we either set the temperature to 65 degrees or 75. The response variable is how well they do on the exam, right? So their grade or their score. Are there other variables that could affect the response? Think about what other variables. So like, could we have confounding variables, in other words, in our experiment about the temperature in the room affecting the outcome of your quiz or test. So the time of the day, for example, some classes maybe happen in the morning, some classes happen in the afternoon, perhaps that, or even in the evening, right? College courses can be in various times of the day. So maybe that's really, people, when you have class at 7 in the morning, maybe people don't do as well, right? Maybe late at night, people don't do as well. So maybe in the midday, people are doing better, right? And it has nothing to do with the temperature, but it really is the time of the day that's affecting. The instructor, right? Some classes might have a really bad instructor, and so maybe they're not doing well because of the instructor, and really the temperature has nothing to do with it. The textbook, right? Some teachers might use a textbook, some might use an ebook, some might use a different textbook. So perhaps the textbook that they were using, maybe the ability of the students. Maybe some students have a better calculus ability than others, and so as a result, the increase is nothing to do with the temperature, but it could instead be that the ability of the students. Some students are just smarter than others when you're talking about calculus. All right, so these could be confounding variables that we can't tell if we don't control for these things, right? We can't control, whether or not the instructor, these classes that did better had Mr. Smith. These classes that did not do as well had Mr. Rodgers. And so as a result, it could be the poor performance of the instructor, right? So that what instructor you have and the temperature of the room could be confounding because we don't know which one is causing the results that we're getting. All right, a couple more terminology issues. A placebo. I think I probably earlier in this video mentioned a placebo. So a placebo is something that looks identical to the treatment, but really is like a fake treatment, right? So if we were talking about the coronavirus vaccine, everybody gets stabbed in the arm with a needle and gets injected with something, but you don't know if it was the active vaccine or a fake vaccine. Something that when they stick it in you is not going to hurt you, but it's a placebo, right? So it's a no active ingredients. Now you might say, well, why do you have to stick somebody? Why don't you just not give people the active ingredient or the shot? And that's because we want everybody, right? What happens if after after I get my vaccine, if I know I got the vaccine and someone else knows they did not get the vaccine, we might act differently, right? So we want everyone to behave the same way, and that way we can say there's no other confounding variables, right? Everyone was treated the same, everybody got the same treatment. So I may act differently if I know I got the placebo and didn't get the actual vaccine, then I might wear a mask more often, and it would throw off the results, right? That kind of thing. So the placebo is just something that looks like the actual treatment, and you don't know what group you're in, right? So that's part of a good design of an experiment. And then we also have a control group. Control group is typically the group that got the placebo, right? So they're not getting an active treatment. So they either do not receive the treatment, but they think they do, right? That's the key. Or they receive the standard treatment. So if I was treating someone with cancer, right? Someone who has cancer, we would give like, oh, I developed this new cancer treatment. So I would have two groups of people who have cancer, the particular type of cancer that this medicine is supposed to help cure. And so half the people would get my new medicine and half the people would not get a placebo, they would get the old or standard treatment. All right, so the whole idea is we want to see is this new medicine better than the old medicine that we were using, and so now we'll have a side-by-side comparison. Again, if possible, the people don't know which group they're getting. They don't know if they're getting the new treatment or the old treatment. And so that's a control group. You either are going to get no treatment or the placebo, or you'll get the standard past treatment. When it comes to medicine, sometimes we don't want, if someone is dying from a disease, you don't want to not treat them, right? If someone has high blood pressure, and I think I have a new medicine to help with high blood pressure, we're not going to give some people the placebo because people can die from high blood pressure if it's not treated. So we give them the old standard treatment and we give someone else the new treatment, right? So we don't, sometimes placebos are not used. Instead, it's just the control group where you get the standard treatment. All right, last thing today, number 11. So experiment. We have 36 subjects. And they were randomly, so these are people who volunteered, and they were randomly assigned into two groups. One group is given an herb supplement, and the other one is given a placebo. After 6 months, the number of respiratory tract infections in each group that each group had, the number of respiratory tract infections that each group had was compared. All right, so for this experiment, or this experimental study, list the following. All right, so what are the experimental units? So in this case, so pause the video and then answer these questions and then unpause. All right, so the experimental units are the 36 people in this study. These typically are volunteers, right? You have to get people to volunteer. And what are the treatments? How many treatments are there? There are two, right? One that's the herbal supplement, the other one is a placebo. All right, and then what is the response variable? Remember, that's what we are measuring. It's what comes out, or the output from the study. And it's the number of respiratory infections that each group got. And we'll compare those, right? So if the people in the herbal supplement didn't get fewer respiratory tract infections than the placebo group, then that tells us the herbal supplement is not effective, right? The explanatory variable, that's basically, did you get the herbal treatment or not, the herb or the placebo, and any confounding variables that might happen here. What do you think? All right, so it could be what else they ate, could be where they live, right? Some people might not live in a great place and there may be a lot of mold, and that might cause, trigger respiratory tract infections and those kinds of things. So there could be other things. And so the whole point is we want the study to be large enough so that 36 may not be, a clinical trial usually has thousands of people in it. And that way, in both groups, everything's going to average out, right? You're going to have some people living in poor conditions in both groups, right? If I only have 2 or 3 people in each group, then they could be different. But replication, or having more people in each of the 2 groups, is going to average out any differences. Okay. All right. So that's the end of this first couple of pages of notes. You should be submitting a picture. Look on the Google Classroom to determine which page you should submit. Off the top of my head, I can't remember.